How you doing?
Pretty good. How you doing?
I'm doing pretty good, yeah. It's a nice, really nice weather these days, I have to say. So it makes everything nice.
Nuclear fission reactors work by splitting more heavy or unstable atoms like uranium.
So let's talk about fission again, because that's one that we can use right now. So you take what do you think about, what atom do you think about when you think about nuclear fission?
Well, I always think of uranium.
Yeah, uranium. Okay, so they found that if you take a big, heavy atom like uranium, that's great. You need something big and heavy because when you split it, you want to get some kind of difference in mass. So it's hard to split a smaller atom but a bigger atom with lots of neutrons and protons, a little easier to split. You want to get one that's kind of unstable, that kind of, with a little bit of encouragement, it could split apart. So you kind of try one that's easier to split apart. And so, yeah, uranium is one of those things. And actually, the isotope uranium-235, isotope is probably a little bit easier, so that's what they use. But in some cases, plutonium is another one. Like in Back to the Future, when he uses plutonium to power the
car.
The car.
Yeah, I remember that. Yeah.
Anyway, so those are two good elements.
He used bananas later on, though, or something, didn't he?
That's right. That'll be way down the road. I think we could get there. But
yeah.
But uranium. So, but what they do is they bombard it with neutrons, and that splits the atom apart into two different atoms, and then you get these free neutrons, few neutrons that come out of that don't have an atom, they don't belong to anywhere, and that's part of the radiation problem. But then these neutrons then bombard another uranium atom, and it splits that apart, and that creates more neutrons that are free, and then those neutrons bombard more uranium atoms, and then it just keeps going off, and that's the chain reaction part. So as long as you have uranium there, it's going to keep doing it on its own. You just have to get it started, which is kind of cool. So it's going to keep going and going.
Nuclear fission reactions are controlled by separators and cooling down with water.
Problem is, you don't want it to keep going to where it explodes, like into this, atomic.
And so how do they control that? How do they control so it doesn't happen or something?
Yeah, they have. What they do is they have to get some separators, these blades that separate the material. That's called neutron absorbers. Things like boron, stainless steel actually kind of works too, because it's a very dense material. But it basically prevents the neutrons from going any further. And so they get these blades, and then they raise or lower them, and allow once they start bombarding the uranium, they can kind of control it that way, where they can expose a little bit more or less depending on how much they want to react. And they also keep it cool with water. It goes back to this whole steam engine concept. They're using water to regulate some of the heat off of that, so it doesn't get too hot as well or over react. Because the hotter something is, the more those atoms and elements want to move around, right? And so then they're going to be more apt to split apart when it's hotter. So they kind of try to keep them cool. That's called a moderator in the nuclear power plants. And water is good because then you can also use the water to create steam that pushes the steam turbine. So turbine.
According to Einstein's theory of relativity equation, nuclear fission and fusion generate large amounts of energy with small mass changes due to the speed of light.
So basically what we're doing is we're taking Einstein's theory of relativity into play here. So either we make a larger atom split into two smaller atoms, which have a difference in mass, or we're taking two small atoms and fusing them together to make a bigger atom, but also has a change in mass. This doesn't equal the sum of the two smaller atoms. And so you have this difference in mass. And remember, E equals mc squared. Mm-hmm. The c squared is the speed of light squared, which is a huge, huge number, right? And the E is energy, m is mass. So you have a change in mass, even if it's a very small change in mass. Because c is a constant, it's going to equal a huge difference in energy, okay? A big amount of energy. So that's what makes it so interesting, and why we get so much heat or energy out from this reaction. So it's kind of but like I said, there in fission, you get some radioactivity from the free nuclei that result from that, and so the gamma radiation isn't so great.
Nuclear fission power could create more industry and help desalinate water due to the extra unused electricity it creates.
I think nuclear is a good way to go too, because if it's 24/7, if you have nuclear power, you should be able to create other industries and keep the existing ones you have, and create a lot more opportunity for us to build different things. And even like if you want to do water purification to give the world, clean water, you can use all that extra energy from
Desalination
nuclear
stuff,
to
right?
do
Yeah.
desalination, like from the ocean water, desalinate it and bring it in, and that would solve a lot of our world's water problem too.
Well, so yeah, let's increase our capacity of electricity output and power output. Let's increase that so that we can do stuff like that. So as long as you got this big nuclear plant going, let's not waste any of that energy. Let's use some of that to solve some of our needs, like what you're saying, water and other stuff. So
The extra energy from nuclear power can also produce hydrogen as well as being carbon emission free.
If we had these if we built more of these nuclear fission reactors or power plants, that would give us an opportunity to produce more hydrogen.
yeah,
And right now, hydrogen is 95% of it is produced from natural gas.
which it takes more energy to produce hydrogen than we would get out of. So
It does. It takes more energy, and it produces greenhouse gases in the process. Whereas if you had nuclear energy, it's already using the electricity that's already being made. The electricity that you would otherwise waste when you don't need it, you could use that extra to produce the hydrogen, and it's emission free. There's no greenhouse gases produced with it. So right now in the United States, we generate about 10 million tons of hydrogen to be used per year. If we started using it for vehicles and other purposes, I think that could easily go up about 10 times as much, say in maybe the next decade or a couple decades or whatever. So we're going to need an infrastructure anyways to produce this, to distribute and produce this hydrogen. So if we make more nuclear plants, we would have some of this infrastructure that we could put in place for hydrogen as well.
yeah, absolutely.
And so each nuclear power plant, if it's like a 1,000 megawatt power plant, can produce about 150,000 tons of hydrogen per year.
The hydrogen from nuclear plants could be used to power fuel cell and combustion vehicles.
But they're not using it so much for fuel, like as a combustion fuel, because it's pretty volatile as an element once it's just pure hydrogen. So they're using it in fuel cells mainly right now for vehicles. Is that right?
I don't know. That probably is right. Yeah, I would think so. And I mean, I think the government vehicles may be more fuel cells, and they're doing a lot of these hydrogen fueling stations, like probably for fuel cell vehicles.
Yeah. So once we were able to maybe make a combustion engine with hydrogen fuel, and safer, then I think that's a great way to go. If we ever get that far, and people don't get too worried about exploding hydrogen, stuff like that.
Yeah.
And the right now, with fuel cells, that's fine too. I think that's great, but that's again those batteries have a tail to them as well. You got the battery issue like we talked about before, but again, that's still a good step. I mean, that's like we said, nuclear fission is a good step. Maybe there's something that we can do beyond that that's not so dangerous, like fusion. We can talk about a little bit as well. But yeah, hydrogen could be solving our transportation fuel problem as well if we produce a lot of hydrogen.
Yeah, so that would take care of 72% of all the emissions. Is a combination of electrical energy and transportation. So if you had nuclear, you could kill two birds with one stone. You could help out the transportation industry and then also electricity as well.
Right.
All right, so our message is if you people are really interested in solving the energy and transportation and reducing fossil fuels, you'll go with nuclear.
Without producing
greenhouse
more poor people.
Yeah, more poor people. Solve the energy and the food and all that problems. You'll go with nuclear energy and help develop fusion power as well.
Well said, brother. Well said.
Yeah.
All right, let's end there.